Okay. Okay, hi everyone. So, yes, so who can tell me like what's the just raise hand. Okay, do not speak without asking me. So, who will tell me the difference between TCP and UDP?
Sir, me.
Oh,
Me, sir.
yeah, Bridge Mohan, tell me what's the difference between TCP and UDP?
Basically, main important difference is like the TCP is a connection oriented and UDP is a connectionless. Always there is sending an acknowledgement packet in TCP.
So
TCP
behave
is
like, speak like the same way you are going to speak in interview.
sure.
Okay, don't be very casual. Like TCP is like that. You will not say these, right? So behave like you are in interview. Yeah. So tell me what's TCP UDP.
TCP stands for the Transmission Control Protocol and UDP is a like I forgot the full form of UDP.
User datagram
Datagram protocols, and TCP is a connection oriented and UDP is a connectionless protocol. TCP like uses the 20 bits of packet and UDP uses the 8 bits of packet.
Okay, so do you know what is three-way handshake?
Yes, sir. Send
Okay.
and CAC.
Okay. So what is the difference between MTU and MSS?
Maximum
Yes, guys, please note down the questions also, because maybe in interview people are going to ask these questions. So I'm asking MTU versus MSS. Anybody can tell me MTU versus MSS?
So can you repeat the question, please?
What's the difference between MTU and MSS? Anybody wants to try? No?
Sir, M2,
Yes.
M2 means sir, maximum transmit unit.
MTU means
by
maximum
default it
transmission
is one. Yes, sir. By default it is 100, 500, sir.
Okay, and what is MSS?
MSS. Sir, I have no idea about MSS.
Okay. I'll give you overview about
for maximum segment size.
Yeah, it's a maximum segment size. Correct. I'll explain the difference, okay, MTU and MSS. Okay, so just who will tell me what's the difference between packet and a frame? Dev. Yes, Dev. What is the difference between packet and a frame? Yeah, Dev, can you unmute?
Packet is a network in network layer. Packet your transmission units are packets, and frames are on data link layer.
Okay. Okay, so that's it.
Frame works in layer 2 and packets are transmitted in layer 3.
Packet has an IP address,
destination
IP address, source IP address
information, and frame has that
frame contains MAC address.
Yes, sir. Yes, sir.
So the guy is only with camera.
Packet are working in layer 3, network layer, sir.
Okay, so let me tell you the difference. So obviously, interviewer is not asking you to just say like layer 3 or layer 2, right? So they need like full details from you, why they are going to hire you. So you need to be very, like extraordinary in the interview, right? So like if somebody is asking you what is the difference between packet and a frame, so you would be saying packet is obviously like it's a PDU. PDU stand for protocol data unit. Okay. Packet is basically like it would definitely works on network layer, but packet contains what? Source IP address, destination IP address, and what else? Anybody can tell me?
Time to leave.
It's with the port number and
TTL
source
value.
port, destination port.
Port, okay.
Port address, source port
Mhm.
address, and
Source MAC and destination MAC.
destination port address.
Sequence
No,
number
no,
also.
no.
Sequence
So,
number.
see, you all guys are wrong. Trust me. I think you need to cover your basics again. So, packet does not have port numbers. Okay. Packet does not have port numbers. Packets have only source IP, destination IP, right? And there are other fields also, like where we have TTL value in packet or in layer in frame.
In packets.
Okay. Have you heard about like broadcast strom? Have you heard about broadcast strom word? Broadcast strom word suna hai?
Yes, sir.
Yes, sir. Yes.
Okay. Or have you heard about flooding?
Yes, sir.
Yes, sir.
Okay. So have you heard flooding or broadcast word in wide area networks in WAN?
No, sir. No, sir.
No, sir.
You have seen maybe routing loop in
The
WAN
routing
maybe.
links,
Loop suna hoga, but have you heard about broadcast or flooding in wide area networks?
LS.
Routers usually
no,
don't
no, not
forward, it
LSA.
will discard
No.
the broadcast packets.
Okay. So router does not forward broadcast. This is what you are saying?
Yes.
And does routers create ARP packet?
Yes, sir.
Yes.
Yes, sir.
Yes, sir. Yes, sir.
What is ARP? Dev?
Address high resolution protocol.
Just
Yeah,
yeah.
to
It's
find
an
the
IP to
MAC,
MAC.
Address resolution protocol.
Sir, it
Find MAC address of a device.
Where it
Okay. Let Dev answer. Just hold on, guys. Yeah, Dev. So I'm asking.
Yeah.
Bridge mic offer ko. Yeah. So I'm asking. You are saying router does not forward broadcast, but
Yes.
router generates ARP, and ARP is a broadcast packet.
Yes, sir.
So how can you please explain why, like, then why router is sending ARP packet if router do not forward broadcast?
Okay.
Tricky question, guys.
Yeah, got it.
Can I answer?
Answer definitely. Let him think thoda sa.
Can you repeat the question, please?
address
So the
resolution protocol,
question-
we can find the MAC address for the,
So the question
application
is-
IP address.
Yeah. So the question is, I asked all of you, like, do you see any broadcast packets or like broadcast stroms, flooding? These are the terms in LAN networks. Okay.
Yes.
Broadcast strom and flooding is a term of LAN networks. You will never
LAN.
see in wide area networks. Why? Because in WAN, like mostly all devices are router, and router works on which layer?
Layer
Layer 3.
Layer 3, layer 3.
Yeah, layer 3, right? Layer 3. Layer 3. So layer 3 in IP header, there is a field called TTL value. How many of you know TTL value?
Yes,
Time
sir.
to leave,
Yes,
time to leave.
Yes.
Time to leave.
Okay. Are you getting my point? Why there is not a broadcast from in the WAN networks? Because we have TTL value in the IP packet, but there is no TTL value in the frame. In Ethernet header, in Ethernet pack, what we call frame. Let me give you idea. Okay, let me ask 2-3 more questions and then we will discuss. Okay, I hope you are getting my questions, guys. Yeah.
Yes, sir.
Okay. Okay, so ARP packet, how many of you know ARP?
Yes, sir.
Yes, sir.
Okay, so let Mahinder answer. Okay, Mahinder, what is ARP?
It's address resolution protocol, and ARP is, as most of the guys I think have answered, to like someone says on the street hello, to get the MAC address of the neighbors, like immediate neighbors, and if it is at the router rail, it creates the routing table also once. No. Yeah, MAC
No,
address.
ARP.
Yeah, sorry. Yeah, get the MAC address, and it creates the, what is the table called with the list of the
ARP
MAC
table
address.
only.
Oh, ARP table, yeah.
Chem
So it
table,
creates
chem
that.
table.
Yeah,
Yeah,
that's the one. Yeah, that's the word.
okay.
Yeah. So this is what I know, not much.
Okay, so ARP is layer 2 or layer 3? Can anybody tell me?
2.5.
Just
Layer 2.5.
2.5 between the router and the
don't you
switch.
think layer 2.5 is MPLS? If you guys know MPLS,
Yes, sir. It's a 2.5
MPLS
is
is called
MPLS.
layer 2.
MPLS rely on a 2.5 like between the network.
Yeah, but I never heard ARP is layer 2.5.
Sir, ARP
This
run on
is
2.3 is.
L3.
ARP is layer 2 or layer 3?
Sir, both layers.
Hello, sir.
Okay.
Actually, sir, ARP find out the IP address to the MAC address. So we can say that.
Okay. So these are the questions for like with what we are going to learn today. Okay. So I hope you got the point and let's start. So the first question, let me remind you guys what question I asked. Just type in the chat. What was the first question you want me to cover? MSS and MTU, right? I asked you MTU and MSS, right? TCP UDP, like that is okay. I think that I do not have to cover. That's very basic. So I'll cover MTU versus MSS. Okay. Yeah, so these are my notes. Okay, so let me create a new file for you all. Did I create it again? No. Okay, so CCNP August batch almost, yeah, 2022. Yeah, so the first thing what we are going to cover, this is day 1. Okay, so the first thing what we are going to understand is what is the difference between MTU and MSS. Okay, so this is what we are going to cover. So can you see this, the total, this is all Ethernet frame, right? Can you see all? Yeah. Okay, so you guys can see this is Ethernet header. This is Ethernet header, and under Ethernet header, you have IP header. And the total, like the total M2 is called maximum transmission unit. How much like device can send, what is the maximum data we can send, that is called MTU. Okay. So the total size or the total value what we are going to transfer is that called MTU. Okay. And if I show you something more. Okay, so you guys can see, do not see the MPLS thing, just focus here. Okay, so if you are sending a packet, okay, and normally MTU is 1500. Okay, so you guys can write down somewhere. So normally MTU size is kitna hota hai? Let me write here. So normally MTU size is 1500 bytes. Okay, but if you are sending a TCP packet, okay, if you are sending a TCP packet is 20 byte. Okay, let's write here. If we are sending a TCP packet, then it is 20 bytes. So almost every packet what we send on internet, or if you are sending even in LAN network, every packet will have IP address on it. Yes or no, guys? Har packet mein IP address hota hai, hota nahi? Yes, in every packet, most of the time you see what? IP, and IP field is also 20 bytes. Your IP is also 20 bytes. Okay, now tell me if you are sending a packet to google.com, this is your PC and this is internet. Okay, so you internet and then we have google.com. Okay. So when you send a packet from your computer, normally, so when PC send a packet to internet, okay, and internet devices send the packet to google.com. So normally when your computer transfer data, that the size of that packet, the total size of your packet maximum is going to be what? 1500 bytes. But right now you are accessing google.com or maybe you open facebook.com, whatever website you open. So because google.com is using what? HTTPS. Yeah. So HTTPS works on which protocol? Yes, type in the chat. HTTPS works on which protocol? 443 TCP. So if we are sending a packet to google.com and we are accessing HTTPS, so HTTPS works on which protocol? TCP. Yes. So it means 1500 is your MTU and 1500 minus 20, like 1480 bytes. So now your computer is going to send how much packet size? अब कितना packet जाएगा? Now we will send 1480. Okay, now tell me, when you send a data, so your computer IP address will be applied or not? Are you going to apply your IP address and google.com IP address? Yes or no? Yeah. So it means we will be going to use the IP address also. So it means we will be also minus our IP bytes, that is 20 bytes. Then your MTU size is 1460 bytes. Clear, everyone? So this is your IP MTU, your total IP header, TCP header, and the data. Payload is called data. Okay, write down somewhere. Payload is called data. Payload is your data. Payload ही आपका data होता है. गंगाधरी शक्तिमान है ना जैसे. Payload is data. Okay, so now IP header plus TCP header plus payload is your IP MTU. Clear, everyone? And then the total data, what we are sending right now, okay, the data what we are sending right now, payload. Okay, tell me what is payload here? 1500 hai? Okay, what is my payload? 1500, 1480 or 1460? Type in the chat. What is my payload? Yes, 1460. Okay, got it, because my IP is taking 20 bytes. My TCP header is taking 20 bytes. Okay, my payload minus 20 minus the total maximum my computer is going to send the data is 1460 bytes. Clear, everyone? क्योंकि कोई भी डेटा है ना वो IP TCP लग के जाएगा. Like whenever you send a data, IP and TCP is applied. Okay, so tell me, in the case if I'm sending ICMP, okay, if I'm now using, if I am not sending TCP packet, if I am sending ICMP or ping, so in this case MTU is 1500, your ICMP is applied. So what is the size of ICMP or UDP? ICMP and UDP both are 8 bytes. How many? 8 bytes. Okay, and IP is 20. So now 1500 minus 8 is your 1414, what we call 1492. Yeah. And 1492 minus 20, 1472. So in the case when you sending data with ICMP, okay, when you are using ICMP or UDP, so your IP MTU size will be 1476. But in the case if you are using TCP, any service of TCP like HTTP, HTTPS, whatever, okay, in that case, your, like in the case of TCP, your IP MTU size is going to be 1460. Okay, and that is also, you can say that MSS, which is maximum segment size. Okay, this is 140 is your MSS. That what is the maximum segment size I can transfer 1460, and here not MTU, sorry, it's MSS. So the my MSS here maximum I can send data with 1476. Okay, yeah, it's two. Sorry about that. Okay, clear. First question, guys. What is MTU MSS? Yes, getting confidence now. 1471. हरदेव कहाँ से देख रहे हो? Okay. Yes, yes. Okay, so this, what was the second question I asked you? Are 146 because you minus 40 bytes, na? From 1500 you minus 40. TCP also, IP also. So this is why you got 1460, and in ICMP UDP 1500 minus 8 1492 and 1492 minus 20 bytes of IP 1472. Yes, yes, Mahinder, correct, correct. What is three-way handshake? That's very basic, guys. I think you should know what is three-way handshake. Okay, ये बहुत easy होता है. इसमें कोई, I think you do not have to go in detail. That's your choice, but yes, how it works. So, looks like I'm teaching CCNA students, and this is a CCNP class. No worries, it's always good to learn the basics again. Because what is the use of going to advanced topics if you are not good at basics, right? So right now you can see there is a computer. Okay, so this is maybe your computer machine and this is the Google server. So whenever you send a packet, okay, that is called sync packet. No, Nihal, that we do not have to subtract or something. Okay, we are discussing about, so sync packet, when you send a sync packet, the server receives the sync packet, and then it will send a sync packet with acknowledgement. Okay, so you can see, but it will, so right now, suppose you are sending a sync packet with a number like maybe let's call 0. Okay, so यहाँ से आप 0 भेजोगे. Okay, so suppose you send a packet with 0. So when you receive this sync packet 0, you are going to send 1 now, because now you are saying, please now send the sequence number 1. Okay, so then you send acknowledgement also, and then the client respond with the acknowledgement. This is called three-way handshake. It's very basic thing, and this is called for connection establishment. तो ये किसके लिए यूज होता है? कनेक्शन बनाने के लिए. Okay, so there is a concept here, four-way handshake also. Okay, four-way handshake, I am sure like 99% students never heard about this term. So basically this is to close the connection. Okay, four-way handshake is to terminate the connection. That's called four-way handshake. That's called, like, you send a fin bit. Fin bit means final bit. So what is four-way handshake? This is all TCP. तो ये four-way handshake क्या होता है देखो. Okay, so just, yeah. So like your computer is sending, like right now the data transfer is done. आपका data transfer हो चुका है. Now you want to close the connection. So how you are going to close the connection? You are going to send a fin bit. This is a flag which is called final bit. Okay, fin bit. That I do not want this connection anymore. That's called fin. And then the other receiver send acknowledgement, and that device also send a fin bit, and then you acknowledge from this send. Okay, fin means I want to close connection. Acknowledgement, yes, okay, fine. Then you say I also want to close connection. Then the other side say acknowledgement. This is how you close or terminate the connection. And where do you see all the connections? You can go to a terminal. Okay, so you can use Windows also. Okay, and type here netstat -f something, or what we call S. Just type netstat here. Okay, so right now you guys can see this is my computer and this is my remote address. This is my foreign connection, and all the connections are established. Okay, right now I'm taking Zoom class and there are other connections also. But right now you can see there are a lot of other connections, and I just need to focus on my, yeah. So you can see this is my private IP. This is the remote IP, and I'm using TCP version 4. Okay, and because HTTPS works on TCP 4. Okay, and all these are connection established, and some connections are like close weight, means they are almost going to close. Okay. So this is what we call, you can check all your internet connections with this command netstat, network statistics. Okay. Okay, so this is 3-way handshake, 4-way handshake, and you should be good at few other topics. Okay. You should be good at basic topics like ARP and all. So let's talk about ARP now. Okay, what was other question, guys? After that, what topic, what question I asked you? इसके बाद क्या पूछा था? Okay, packet versus frame. Okay. So for packet versus frame, I would all request you to go and watch my OSI model so that you will get a complete overview. Recently, I just uploaded a video on YouTube. It's in Hindi also, and there is English videos also. So just watch my OSI model. Okay, it's uploaded on YouTube also. Okay, I think, and that's, you should watch. Okay, so let me show you something. So to understand OSI model, just you need to remember this image. Okay, so whenever somebody asks you question about what is packet, frame, like I asked you one question, what is the difference between segment and frame? Right, this is the question. Or maybe somebody will ask you what is the difference between frame and or you can say what is the difference between segment and frame, or packet versus frame. Okay, so what all, you need to first understand all the layers, then only you will be able to answer all this. Okay, just remember one thing. On your first 3 layers, the data is called data. Okay, तो पहली 3 layers पे data को data ही कहते हैं. All first 3 layers, the data is called data. And the transport layer, we get the data, but on data we add another information which is called segment header. क्या डाल देते हैं इसके ऊपर हम? We upload a data, like on data we add a cover, or you can say encapsulation. Whenever we add something in the data is called encapsulation. So you can see when you come from top bottom layer, top to bottom, so the process is called encapsulation because all layers is adding data. And whenever you remove the headers, this is called de-encapsulation. Okay. So the data is here. So we add a segment header. What is inside the segment header? Yes. Anybody? What is inside the segment header? Like if you need to understand then TCP header. तो आपको इसके लिए पूरा TCP header पता होना चाहिए. Okay, you should be very good at TCP header. Okay. Like if I go and show you, like to understand segment header, it's not the start. This is not the end. This is the start. So this is your TCP header. And this is actually your segment header. Okay. And now understand when the data goes from segment to segment is added, then transport layer forward data to network layer. And on the network layer, we add which data? Packet header. So this packet header is nothing but your IP header. Okay, which header? IP header. So it means you need to good at IP header. Okay, yani ye jo packet header hai, this packet header is nothing, just it's a IP header. Let me add here. I copy this. Okay. Yeah. So this is your IP header, IP version 4, because you are using IPv4. But if you are using, your computer is using IPv6, then your packet header is not going to be this header. Then the data is going to be IPv6. So now you understand transport layer. This segment header is going to be either TCP or UDP. So if you are sending data with TCP, then all these fields will be applied. When the data moves to the network layer, all the IP header details will be applied. When the data moves to data link layer, so you can see the data is still data is here. Segment header is copied from segment also. In packet also you have a segment header. In Ethernet frame also you have a segment header. In packet header still here, and there is new added here which is called frame header. Now frame header is nothing. We are 802.3, which is called Ethernet header. Okay. So ये जो field है, so this field is your 802.3 header. Okay, means whenever you send a data, so your data is going with these three fields. I never explained in such a way to the CCNA guys because that's very difficult for them to understand. But this is a CCNP batch, so this is why I'm going in deep. I hope that makes sense. और तो मैं भी थोड़ा आज ज़्यादा दिख गया है. Okay, so it means whenever we send a packet, the packet, just imagine when you are listening to, like right now, some guys are watching me on YouTube. Okay, just understand. Okay, so whatever data they are able to see now with HTTPS, suppose you are listening to YouTube music. Okay, so there is a new song which came and you are listening. It means when you are listening that song, okay, from YouTube, so that data is, this data is your YouTube song. Okay, then first the transport layer adds all these details. Are you able to understand now? Transport layer adds all these details like source port number, destination port number, sequence number, acknowledgement number, and these are reserved bits. Okay, and these are control flags like sync, urgent. There are a lot of flags here. Okay, window size. What is your size of your computer to send the data? What is the maximum your computer can send? That is called window size. Okay, means you need to be understand. So this is a checksum. Okay, urgent pointer and all. So we need to learn the TCP header. Okay, so the TCP header, UDP header, UDP I have to check, but the TCP header, IP header, and the 802.3 header. After this class, I'm going to share all three videos with all of you so that you guys can watch and prepare yourself for the interviews. Okay. So gives a thumbs up in the chat. Okay, so we will be uploading these videos and so that you guys can watch. Okay. Okay, तो ये तीनों चीजें जो है ये आपको पढ़नी है. And this is mandatory because if you are going for any TAC interview, okay, so you need to be very good at TAC, all these things to clear the TAC interviews. Even though you are not going for TAC, still many good companies are looking for these things. Okay, it means you need to be expert at TCP header. You need to be very good at UDP, IP and all. Okay, so is windowing is altogether a concept? No, Rathod, windowing nothing. Like I hope you got to know what is three-way handshake. सभी को पता लग गया ना three-way handshake क्या होता है? Yes, everybody knows. So windowing is nothing like what is the maximum size you are sending to, like what we call, like, let me give you some idea. I'm just looking at some picture. I got one file. Okay, so there is a concept called TCP windowing. Okay, so just let me cover this. So TCP header. Okay, so all these three, I'll add a link here, or maybe that's uploaded to your portal. And now if we talk about TCP, the image is not good. Just hold on. Okay, I got a screenshot. I think that this will work for me. Yeah, so I hope you guys can see my screen. Yeah. Okay, so this is a sender. Okay, suppose this is your computer. So right now, first of all, you need to understand, like there is a MTU. Okay, so right now I told you, like suppose a computer is sending, normally computer do not send data with 1500 bytes. Okay, so normally it is like 1460 in the case of TCP. I told you MSS. But let's imagine if you are sending a data with 1500 bytes. Okay, do you think every time you send a packet, okay, and your receiver is going to acknowledge you? Just imagine in the real world. So when your computer is transferring the data, okay, do you see every time, because 146 byte is very small, right? 50, or let's call 1500. So normally tell me, if you are listening to a music, normally one music file is of how many MB? Normally let's call 5000. 5 MB is 5000 KBS. Yes, everyone? And if 5000 KB, if I convert 5000 KB into bytes, then I have to add 3 zeros extra. Yeah. This is 5 MB is 5000 KB and 1 KB is 1000 bytes. Then I have to add 3 zeros extra. So 5 MB song is your like almost 5 million almost, right? So this is how many bytes we have in 5 MB. So if I divide this with 1500, okay, because your one packet maximum your computer send 1500, let's call. But normally I told you 1460. चलो आप imagine करो 1500 byte का जा रहा है. Okay, let's imagine 1500 byte is the maximum. So now if you want to listen one song which is or download a file with 5 MB, so your computer process almost 3300 packets. Just for one song, one file, 5 MB file, 5 MB is almost your 5 million. Okay, so bytes. And if you convert, because your maximum MTU is 1500, okay, but if you see practically that MTU will be for 1460, but let's call with 1500, okay, and if you divide this MTU with this number, okay, 1500, then your computer is sending almost 3300 packets. So now just imagine, आप सिर्फ ये imagine करो, now just imagine, if you are just downloading a file of 5 MB, do you see like your computer is getting 3333 acknowledgements from the receiver? Okay, Mahinder, let's not call music, let's call file here. Okay, let's not talk about TCP UDP. Just focus on the topic because it will redirect me then. Okay, consider a file, okay, 5 MB if you do not want to understand from the music perspective. So your computer is processing 3300 packets. So now just imagine if you are listening to music or whatever you are doing for 5 MB. So do you think a receiver will give you 3300 acknowledgements? I'm asking all of you. क्या आपको लगता है 3300 acknowledgements मिलेंगी आपको real world में? Do you think you will get 3300 acknowledgements? Boys and girls? Okay, can you check now? Okay, but you will see some background noise because I'm using my laptop mic now. Okay. Okay, so I was asking all of you. Okay, just focus here. So I was asking all of you that if I'm downloading a file of 5 MB, so my system is processing 3300 packets. So will the receiver give me, or if I'm the receiver, do you think I'm going to send 3300 acknowledgements? No. नहीं करेंगे ना, इतने acknowledgement पे तो like there is an attack, right? This is the attack, what we call acknowledgement sink attacks or whatever, right? So obviously this is going to be very, very like problem for us, right? So then we need to understand what is windowing. So windowing is basically the limit, what is the maximum, like we will send a data and then only we will be going to get acknowledgement. Means if I am going to send 3000, then only the system will give me acknowledgement. This is called windowing. Okay, मतलब मैं बड़े data पे acknowledgement लूंगा. I am not going to take the acknowledgement on the small number of packets or small size of packets. I'm going to take acknowledgement on the bigger size. Okay. So this is called windowing. Okay, let me give you more idea on that. How we can do that. Okay, that is done by systems only, like Windows and all. I really want to show you something. Just hold on. Big size means like if you want to process big packets, na? Okay, so you can just hold on. Let me show you because I believe in showing the data rather than speaking. Okay, so that is basically like you can see a host. Sometimes we use yeah, Hardev, just hold on. But my yeah, Uday, there is a jumbo frame. That is a different concept that is used in LAN networks or data center networks. Okay, if you want to increase the limit of MTU. Okay, so you guys can see request for data window size 12 KB. So now computer has decided that my window size is 12 KB. So it means 12 KB, if you multiply with bytes, it's around 12,000 bytes. So what is the window size now? 12,000 bytes. Okay, it means computer is going to transfer a lot of packets so that it will give you 12 KB because your computer only requested window size 12 KB. Then server is going to respond with the data 12 KB. And then the computer is going to acknowledgement for 12 KB. Are you getting my point now? Earlier, I was processing around 3,300 packets, but just imagine if your computer has a window size of 12 KB. So in the same case, like if I use my calculator again, I told you like we have 5 like this. And if my window size is 12,000, because 12 KB is 12,000 bytes. Okay, in this case, my computer is going to send 416 packets. It's way less than what we were doing before. So this is the use of windowing, and it's not 12 bytes always. It depends on the operating system. Okay. The window size can go up to like big size file also, like 65,000 bytes also. Okay. You can search for TCP window size. Okay. And you will get to know, like if I Google it, okay. So you can see TCP window size, you can see the TCP window size field controls the flow of data, and it can go up to the TCP window scale is an option used to increase the maximum size, and normally it can go up to 65,535. Okay, it's a big size. Okay, you can send with big size files also. And there is a Microsoft website. Okay, you can see here. You can read this document in a free time. Okay, so there is a research paper also on Windows scaling. Okay, you can search for RFC 1323. This is a research paper. Okay, for TCP extension for high performance. Okay, so it's all about like how much deep you want to go. Okay, this is a research paper. This is 1323. You can search for that if you want to know more. Okay, so normally like computer is sending like if the window size is 65,535 bytes, just imagine. तो अगर हमारा size जो है, if my window size is 65,535 bytes, in this case, my 5 MB file, we will only process 76 packets. Okay, means 76 acknowledgements. We will still send 3,300 packets, but we just have to acknowledge for 76 packets. If my so फायदा क्या हो रहा है windowing का? What is the major benefit of windowing? That my system do not have to give acknowledgement for each packet. I will collect a big data. Okay, like big block of data, then only I'm going to acknowledge the data. Okay, so you must be thinking, what if your data break down between a window size? Okay, suppose you are sending a block of data, like I will send you 3000, then only, because they decided, both computer decided a window size 3000. Okay, so suppose after 1500, 3000, we get acknowledgement. But next time when we send 3000, one packet got dropped. It means then the device is going to give you acknowledgement and it will ask for the window size 1500 and also ask, can you send me the data from acknowledgement number 3001? Because whenever you send a data, every data, whatever you send from computer to server and all, they all have sequence number and acknowledgement numbers. Okay. So if you see the TCP packet also, so in the TCP header also, you see for every data, I have a sequence number, because whenever I send a data, I put a sequence number. And from the remote side, if I get acknowledgement, that also has acknowledgement number. From these two values only, इन्हीं दो values से हमें पता चलता है, from these two values also, we come to know which data is lost, which data we need to retransmit, like which data we need to retransfer again. Okay. So I think that's enough. I think, so this is how it works. I told you, like if you are like in short, what we learned. So whenever you listen any song, whatever you do it on YouTube or whatever, okay, so all the layers add their data, your application data, your TCP data, your IP header data, your Ethernet header data, and all these layers then convert your data into 0 and 1 form. Okay, and they are called binary language or machine language. Okay. So I hope the answer is almost clear. You just definitely, I told you, like you need to watch TCP header. Okay. This IP header. So this is IP header. Okay, in the IP header, you can see version. This is internet header length. This is type of service. This is for quality of service. This is the, like which version you are using, IPv4, IPv6. All these things are discussed in that video. Okay. So you can check source address, destination address. This is a protocol field. Okay. Now tell me, like if I'm taking your interview, guys. Okay. So just understand, just see this header. I hope everybody able to see. Okay, I hope everybody has this picture in their mind, just to see this protocol field. Okay, now I want to ask one question to some of you. Who is going to volunteer? Don't be shy. I know you guys can crack that question. What easy question hai? Yes. To whom should I ask? Yeah, Hardev, you want to try?
Yes, sir.
Okay, so I shown you protocol field. Okay, so tell me, if you are sending TCP packet, your router does not understand TCP, right? Yes or no?
I guess yes.
Yes or no?
Yes.
Okay. Okay. Are you sure? Router understand TCP? Okay. By the way, BGP works on TCP port number 179.
Right.
So now tell me, router understand TCP?
Yes, sir, definitely.
It can process the traffic. Okay. It can process the traffic, but obviously, have you do you think that router create a TCP table like computer? Like I have shown you netstat, right? Netstat dekha na abhi humne. We have seen the netstat. Do you think that is what we call connection table? So do you think router also create a connection table?
No. Router creates routing tables, processes
Okay, I'll show you all of you, okay, in BGP class. But by the way, so you can run show TCP brief all command on router. Show TCP brief all. Okay, show TCP brief all. Okay, so I was asking, like when you send a data, like when you send, like you are a router, like you are a Delhi router, I'm a Chandigarh router. Okay, so we both are routers. You send a data in the form of packet to me. Okay, so your router process that packet, convert all data into 0 and 1 form. है ना? Router 0-1 में form convert करेगा. Router is going to forward packet in the 0-1 and I'm going to receive 0 and 1. I'm going to convert into frame and the packet. Then when I'm going to read the content of packet, okay, so how I'm going to come to know that you send me TCP packet? Router को कैसे पता चलेगा? Or any device, let's not call router, let's call any computer, because computer first check the packet, right? Before going to the application layer. Yes or no? Receiver end, I'm asking all of you. जब हम receiver end पे होंगे तो हमें data नीचे से मिलेगा ना? When we are at the receiving end, we will receive the data from the physical layer. Yes or no?
Yes, sir. Yes.
Yeah, so when we receive the data at physical layer, when we check the IP, what we call MAC address, all those details, when we open the packet, how we will come to know that this computer is requesting for HTTPS or HTTP
port number?
Yeah, that's there in the port number, right? But remember one thing in transport layer or in network. Listen, my question, what I'm asking, very critical question. So I'm asking, when you send a packet, okay, that I want to access website. So data link layer, MAC address. In network layer, we will understand packet header. In the packet header, how we will come to know which transport layer protocol you are using. In transport, maybe the packet is TCP, maybe the packet is UDP, maybe the packet is ICMP. Yes or no?
Right.
Are you getting my point? When this layer understand packet, when it opens the header, he checks this field which is called protocol field. Which field?
Protocol.
Got it, guys? तो जब नेटवर्क लेयर पे पैकेट आएगा तो क्या देखेगा? Yes,
and
yes.
What will be there in protocol field?
Yes, that's what we are discussing here. Okay, so let me show you something. When the network layer sees this IP header, it checks the protocol field value. In the protocol field value, we have all these protocols. Can you see that? Now I have added a screenshot here. Yeah. So if we are sending a TCP packet, then the protocol value will be 6.
Oh.
Are you getting my point? Yes, so if I'm sending a TCP packet, okay, I think you all guys have to what we call packet tracer. सुना है CCNA में software था.
Yes.
गलती से खोल लेता है.
Yes, sir.
अच्छे से खोला नहीं लगता है CCNA में. Okay, so no worries. Okay, so right now, so there is a computer here. Okay, I'm using a server here. Okay, so even I know this is the first class. I can show the big labs also, and I can show all those stuff. But I think the basics are more important. So by the way, how is the class going on, guys? Good, bad, awesome, super awesome.
Super awesome.
Awesome, sir.
Okay, so this is server, right? I have given IP address here 1.2. So now if there is a mode here in Packet Tracer, if anybody has never installed Packet Tracer, so it's a free software you can download from Cisco Network Academy. Okay, and there is a Packet Tracer video on my YouTube channel also, you can check. So now you can see simulation mode. Okay, so in the simulation mode, you can see what computer is sending. So now if I click on ping ICMP, okay, just hold on. Okay, I'll go to simulation mode again, go to computer. type here IP address of your server. Let's use web browser. In the web browser, I'm going to enter the server IP 1.2. So now you can see 2 packets. Yes or no? Yeah?
Yes, sir.
Can anybody tell me why we have 2 packets here?
One for R,
R,
second for ICMP.
Yeah. So because even this is a question from interview. So we send ARP with ICMP or with TCP. So interviewer will confuse you that we send ARP packet with ICMP or TCP. So what should be your answer?
TCP.
Either of the protocol. Both will use ARP. Are you getting? IP header के लिए चाहिए ना MAC address and all those details. So what is ARP? That please can you give me your IP, what we call MAC address? Because I have your IP address. Can you give your MAC address? So we will not send TCP packet. We will hold this packet, but we will send first ARP packet and get the MAC address. And then I'm going to send the TCP packet. Now this is TCP packet. So when I open this TCP packet, okay, so in the outbound PDU details, okay, so I told you all 3, right? Ethernet, IP, TCP, yes? Yes. Yahi sab hai na? So this is your what? TCP is your which layer? Transport layer? तो मैं नहीं बोलने में जा रहा हूँ.
Yes, sir. Yes, sir.
Okay, so the TCP is your transport layer. IP is your which layer? Network layer?
Yes, sir.
Can you see all the fields what I have shown you in the headers?
Yes, sir.
Okay, which packet we are sending right now?
R.
No. Now this is TCP packet.
Just a TCP packet.
But how so when you send this packet, computer is going to receive the packet with which layer first? Which पहली कौन सी layer पता चलेगी उसको?
Physical.
Computer is going to get physical and then data, then network. When it comes to network layer, he reads IP address, right?
Yes, sir.
Mic off, Bridgemon, Hardev, Amzad. You just have to speak when you want to acknowledge. Okay. Use space bar. I told you use space bar. Okay. Use space bar. Okay. So I was saying, like, this is my computer. When I'm going to send this packet to my second computer, when the computer understands network layer, how computer will come to know that I'm sending a TCP frame, UDP frame, or ICMP data? So because when you open the detail, so you can see I'm sending a protocol field layer 06. Can you see that, guys? Protocol field 6.
Yes.
Yeah. Okay, so before TCP I sent which packet? ARP?
ARP.
So what is, like, if I'm sending ARP, how the system come to know that we are getting ARP? Because in the protocol field, the ARP value will be changed and the protocol field, so can you see? No. Can you check? This is not IP header now. This is ARP. Then how computer come to know that I'm sending ARP packet here? Maybe I'm sending some other field. Because ARP directly work on which layer? Ethernet layer. Right? And can you see here ether type? Can you see the type here? Yes. Can you see this value here? Type 806 something?
Yes, sir.
दिख रहा है सभी को? तो इसको क्या बोलते हैं? Okay, I hope everybody at least got to know what is protocol field, and these are the value. If you are sending TCP, value is 6. If you are sending UDP data, the value is 17. And if you are sending ICMP, the protocol number is 1. Okay. Hello.
Yes, sir.
Yes,
sir.
Okay. So now in Ethernet header, we have ether type. Which field? Okay. Yeah, Abrar, I'm getting a lot of voice from your side. Abrar, please turn off your mic. Okay, so another question, guys. If I'm using IPv6, if I'm using IPv4, or maybe if I'm sending ARP packet, how the other device come to know that which layer 3 information I'm sending? TCP, UDP, all those things are your layer 4, right?
Yes, sir. Transport layer.
So if I'm sending ARP packet, how this server come to know? If I'm sending maybe IPv6 header or IPv4, all these comes under which is called ether type. क्या बोलते हैं इसको? Ether type. Okay, so there is a term called ether type. In the Ethernet header, there is a field which is called ether type. Okay, ether type. Okay. जब ज्यादा हो ना बता देना.
Okay, sir.
So this is the ether type field, and you can see this is the frame, and this is preamble, destination MAC, source MAC, and there is a 2-byte ether type field. So if you are sending ARP packet, okay, if you are sending IPv4 packet, the ether type value will be 800, and if you are sending ARP packet, the ether type value will be 806. And let's call, normally you just have to remember 2 or 3. Just you need to remember IPv4, IPv ARP. बस ये दो की वैल्यू याद रखना ही ज्यादातर. And maybe if you can understand about MPLS later on. Okay, and what else is required? Rest all are okay. You do not have to look for another one. I'm just checking if we have IPv6. Where is that? Yeah. So for IPv6, you just have to remember these 3 ether type. कर लोगे आधे 3?
Yes, sir.
Only 3.
Yes, sir.
कर ही लोगे तभी कुछ होगा. Okay, so you just have to remember. Even I remember all these 3 only. Okay, not every one. Just hold on. Color red. यार खुद हाईलाइट कर लेना, हो नहीं रहा. Okay, so ether type and the protocol field. Okay, so ether type field is in which frame? In Ethernet frame, and protocol field is in IP header. So the most important interview question, okay, from Ethernet header is what is ether type? So ether type is a 2-byte value. It's a 2-byte ether type is a 2-byte value which tells which network layer, which layer 3 information, or which protocol we are carrying. Okay, which protocol we are carrying in Ethernet frame.
So protocol, is it not saying in the above one, the one you mentioned above, protocol?
Yeah. So ether type, okay. So Ethernet type, like suppose Ethernet header, in the Ethernet header, like, yeah, so this is the field and we need to add here. Yeah, so like this. So now understand, whenever you send a data, you send detail, your 01 convert into Ethernet frame, right? Just understand again this flow. So when the data will receive 01, then it will come and check the Ethernet header, right? The second layer is data link layer, yes?
Yep.
Okay, so when we check the data link layer, inside the data link layer, I'm going to see which information I'm carrying in the Ethernet header. Okay, now based on that ether type, the 2-byte value, I will come to know I'm carrying IPv4 address, or I'm carrying ARP packet, or maybe I'm using IPv6, then the 86DD. So now tell me if I'm sending TCP I will forward my TCP either on IPv4 or either on IPv6. Yes. But if I'm sending TCP version 4, I will use what? IPv4. Yes. Agree everyone?
Yep.
So जब मैं कोई TCP packet भेजूंगा, whenever I'm forward TCP packet, I'm going to use in this Ethernet header my ether type. This ether type value will be 0800. Okay. So now if you go to packet tracer and if I show you what packet, I'll show you the TCP packet. So this is a TCP packet. You can see TCP. So TCP packet A, you can see there is a TCP written over here. Okay, we do not have ether header because right now we do not have MAC address. So this is why we are sending ARP. But when we are forwarding ARP, what is my ether type value here? 806. Can you see that?
Yes, sir.
Because I'm telling my device to send ARP because in ether type I've used 806. But when I learn the MAC address, then I'm going to forward TCP. And in the TCP header, now because I'm sending now TCP packet. Now, can you see the type is changed to 800? It means I'm using which protocol? IP version 4.
IP version 4.
Right? From here, I come to know I'm using IPv4. And then we check IP address detail. Then I come to know I'm using protocol number 6, which is TCP. Like each layer is responding, helping other layer. Okay, that in this layer, Ethernet layer, you inform the device, okay, I'm using IP. So when it checks IP, then IP tells you that you are using a protocol field 6, then protocol 6 is TCP. And then in TCP, we come to know, okay, we are using HTTPS or HTTP with the port number. Are you getting right?
Yes, sir.
Yes. TTL value difference. May I know what the reason?
What?
Sometimes TTL value is different. May I know what the reason?
TTL is a different concept. It's a big topic now. Even I can explain TTL for half an hour or 1 hour.
Okay, sir.
Okay, we'll cover TTL. Yeah, so don't worry. TTL is something which is like I asked you all, like when we are transferring the data right now, these are layer 3. Okay. And if you see in all the values, I'm sending a TTL value. Okay. TTL value 128. Okay. So basically TTL value is called time to live, right? Time to live. Okay. And this is just like expiry date. Just imagine if you send your internet, okay, on internet or routers path. Just hold on. Let me show you. Okay, so your routers are taking a path, right? Yes, when they forward data to somewhere, they check routing table, all those stuff. So this question is clear, right? What is difference between packet, segment, all those questions you will be able to clear now? Yes, I hope I have answered that. Now tell me what was the other one? उसके बाद question क्या था? What was the next question?
The question was
And if router don't broadcast traffic, how they send the ARP packet?
So basically, router do not forward broadcast when we are receiving from other network. Are you able to understand? Now let me show you. If I am going to use a router here, 4331 or like this, okay, there are 2 routers. I'm going to connect a cable. Okay, let's add a computer here. Can we connect a, just for demonstration, can I connect a laptops directly with the router?
Yes, sir.
Okay, at least you know this. But normally in industry, we will not waste ports, right? Because router ports are very costly, right? So just understand there is a LAN network here, maybe 192.168.1.1. Okay, so there are 2 networks which I'll be going to configure. Okay, so anybody here who said, I know everything what you explained today? Just wanted to check.
सर गेटवे रह गया उसमें लैपटॉप।
हाँ कोई नहीं देते। Okay, so which packet is this? ARP, right? Can you see that, guys? When I just enable the port, the first thing the device is sending ARP to each other, right? Can you see that?
Yes, sir.
Okay, let's come to the real time and let's give a gateway here 192.168.1.1. Okay, so there is GI00, GI00. Okay, normally you do not give this slash value on WAN networks. We use /30. Which one? On WAN connections, we use /. Okay, so there is a homework for all of you. You have to do subnetting for like /30. Okay, it means you need to required host is 2 computers or 2 routers.
Yes.
Okay, use 192 network. I hope everybody knows, but still those who do not know. Okay, so without routing, will they ping each other?
No.
No.
No, sir, no.
So what we have to do? Static routing.
Static routing, IP route.
So IP route, how we add a static route? We need to add a route of this network.
Yes,
Okay,
sir.
can I? Okay, so because this is CCNP, I'll explain little more advanced things. Okay, so like if I want to only, like there is one computer only, but I think let's connect a switch here for just a demonstration. Okay, now I have to remove the cable. Any change? All do I have to configure a switch now, or it will work without any configuration?
Without any configuration.
It will work without any configuration.
Yeah, because we do not have any VLANs, all those stuff, right?
Yes,
It's
yes, yes.
okay
Yes,
to
sir.
not.
Yes.
ये क्या होगा था यार? Just hold on. Where is my? Okay, just hold on, guys. Exit from screen. So this is 192.168.2.3. Okay, so tell me any static route. Okay, listen me carefully. I'm saying you need to give a static route where this computer can only ping 2.2, not 2.3 without ACL. Yes. Is it possible?
Yes, sir.
Yes, sir. IP address in the IP route one.
Which IP?
192.168.2.2.
Okay, means I have to give a static route for the computer only.
Yes.
Yes, sir.
Okay, so tell me 192, I want to ping 2.2 computer. So I will give only IP route 2.2. What will be the subnet mask?
/255, 255, 255, 255, 255, 255.
Okay. And next
one
hop.
Stop is
1.2.
Okay, this is called host static route. ये जो भी मैंने पढ़ा है, this is called host static route, and this is used for like servers, and this is also used when you do not want to give access to any other devices.
Sir,
okay,
the subnet mask is 255.
All 255 in the host route. All 255 you have to add.
So if we want to ping a single PC,
just let me give the full network from this side, because this side we are okay with both. So here we are giving the normal static route, because in normal static route you give network ID and the subnet mask and the next hop, right? But in this side, on this router, we have given the host route. Host route means I just want to connect with this machine or maybe a server. So this laptop is able to ping 2.2. Let's see. Ping 192. 168.2.2. Okay, before I ping all this thing, so I want to show you in the router, there is a command here, show ARP. So right now, can you see your own IP address, MAC addresses? I'm showing you the first router 0. Okay, let's call router 0, and this router, let's give a host name router 1. Okay, so guys, tell me with R0, so what do you see? Your own MAC addresses? Yeah? Yes?
Yes, sir.
Okay, so if I ping 1.1.1.2, if I ping 1.1.1.2, my router is going to show me 1112 MAC address also. Now I have pinged. So how many of you think we will have ARP of 112? If yes, type yes in the chat. If no, then type no in the chat. Will I able to see the router MAC address 1112 in the table after ping show in the router? Okay, everyone is saying yes. And this is used for troubleshooting also. Okay, I'll explain you. But if I show you ARP, so you can see 11112. And now, right now, you are able to see the MAC address of my GI000 port. Okay. So sometimes whenever you have internet connection, okay, suppose you are connected to internet and your link is okay. Okay, your link is up, your link is not down, but still your internet is not working. Then you have to check the router ARP that I am able to learn the MAC address of my ISP gateway or not. Okay, this is the best way to troubleshoot, so that you can give it to your ISP that I am not able to learn the MAC address, maybe due to some devices damage, right? Okay, because if this link goes down, both side ports will be down. But in the real world, between your router and your ISP, you will have a lot of devices. Okay, there are like mux, multiplexers, there are a lot of devices. So now just imagine if the link is not down between this device, and just imagine if the link is down between these two devices, then if the link between multiplexers and all, if this link is down, do you think router will show the interface down? क्या आपको लगता है interface down होगा?
No, sir.
Do you think router interface will go down?
No, sir. No, sir.
No, it won't go down.
Most of the time, if there are some devices, so it will not show me down. And in that case, you will see, okay, you will see and check, okay, my link is up. Then you will try to ping google.com. Can you ping google.com if your link is down?
No, sir.
No.
No.
Okay, then what we have to check then?
It will show
Trace route.
Check if they're able to get
protocol is down.
Trace route.
Trace route.
Trace route इतनी जल्दी नहीं करते भाई. Trace route, you are directly connected. Why you need trace route? ISP router से directly connected हो ना? Yeah, you will not do trace route. You can check ARP that you are learning the MAC or not. Okay, you can see the same example. You can put a switch between these two router. Okay, आप एक switch बीच में लगा लो, and then you can demonstrate yourself. Okay, clear?
Yes, sir.
But yes, we will be able to see that router is also sending ARP. Now, if I'm pinging 2.2, if I ping 2.2, do you think router will save the 2.2 MAC address now?
No.
If I ping 2.2, the router, this computer send ARP, we learn ARP. This is why first packet got dropped. And then from now you can see, and now the computer also got the ARP of my gateway, right? Yes, I installed the router MAC address in my ARP table. So now if you check ARP, so what do you see? Do you see 2.2 MAC address here or IP? No, but we store the MAC address of my next hop 1.1.2. Yes? Yes or no?
Yes, sir.
Yes, sir.
And also you have stored your LAN computer MAC address also. Can you see 1.2 MAC address? It means all LAN devices, all their MAC addresses, all you will see in the router tables if they are active. मतलब हर एक LAN device का MAC address आपको router में दिखेगा if it is connected directly with a normal switch and router. And if it is connected in your company, if it is connected with there is a multi-layer switch, all those ARP, all those MAC addresses you will be able to see in the multi-layer switch. Okay, not on the router, because between router and your computer there is a multi-layer switch. That I hope everybody has seen a video which I have given last time. How many of you have watched?
Yes, sir.
Yes.
Okay. So you got to know, like, but can I ping 2.3 now?
No, sir. No, sir, because it is not done.
Because we added a which static route we added?
Host static.
Host. Single host.
Yes. We added a host static route. Can someone share? I was not present. Okay. What do they? Which video? Okay. That video. Okay. So that is actually uploaded into your chat platform. Go to that and check the pin post in the Noisy app.
Sir,
okay, I hope every.
So why it not store the MAC address of 2.2 when it?
Because that's not connected to my network. That's not directly connected to me. That's not in my network. And I cannot forward ARP packet to the WAN connections. Are you getting my point? I can just connect. I can only forward ARP where I'm connected. Okay, tell me just simple thing. Show IP. You need to run this command. Show IP route connected. Okay, which two networks I have?
Yes, sir. One.
Only from these two
Static
networks
route and yes, sir.
Yeah. 1 and 192, I am able to learn the ARP only from these two networks because they are directly connected to me. So this is why if you check ARP, you see these ARP from your own networks. Yeah.
Yes, sir. Thank you so much.
Got it? Clear, everyone? Okay, it means the 2.2 MAC address will be stored by this router, right? So you can see we have stored the 1.1.1 and 2.1, and you can check again, show IP route connected. So these two networks are connected, and this is why I'm able to check. Can you see that? Yes, everyone.
Yes.
Clear?
Yes, sir.
Need a break?
Yes, sir. No.
Yes, sir.
No. Yes.
Yes.
I think let's take a break of 5 minutes, not too much.
So one question before you go.
Yes.
My
Tell me.
space bar is not working sometimes, like by pressing and holding. Sometimes it works,
Okay.
sometimes it doesn't work.
Get a keyboard, bro.
This is a new one. Thank you, sir. See you in a bit.
Okay, I'm back, guys. Hello, hello, hello. I'm audible. Hello.
Hello, sir. Yes.
Yes, sir.
Yes.
Hello, hello. Okay, okay.
Yeah.
Yes, sir.
Hello,
Audible.
hello.
Yes, sir.
Okay. So now the basic static route is clear, right, everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Clear.
Okay. So I think if I cannot start a new topic now, but yes, what I'm going to cover tomorrow, that I'm going to show you. Okay. So
Okay, sir.
that is okay, so that you guys can come and read. Okay. So this is the CCNP ENARSI book. Okay, so if I show you, this is the chapter 1 what we am going to cover. Okay, and if I scroll down, so what we have to learn here, basic IPv4 addressing. I'm sure all of you know what is IP addressing, right?
Yeah.
Yeah.
Yes, sir.
Okay, so the question is like IP. So just have a look here. A network address is a in IP address we have a network part and the subnet part, right? Yeah.
Yes.
Yes, sir.
So how PC1, PC2 communicate with each other? So this is the question. So when PC1 needs to communicate with PC2, it does a DNS lookup for the IP address for PC2. The IP address 10.1.1.20 is returned. Okay, now PC1 needs to determine whether PC2 is located in the same subnet. How? Actually, the question is, this is, I remember, I have given an interview for a US client. So actually HCL, I am sure everybody knows HCL, HCL Noida, right?
Yes, sir.
Yeah, so in
Yes, sir.
HCL, that is, yeah, so that interview was not for HCL Noida, that is for HCL USA. Okay, US. Okay. So I just randomly applied for that position. I thought to get on site. Okay, so I applied, and I remember I was just having 2-3 years of experience that time. So the interviewer asked me, okay, so when two computers wants to communicate with each other, what is the first thing they will do? And I said, first computer will send what? You will also say the same thing. Computer, when you type or try to communicate with PC2, the computer will send ARP packet. Yes, either it is TCP, UDP, whatever. Computer send ARP packet first. Yes or no? In the LAN network.
Yes. Yes.
Yeah, yeah.
Yes, sir. Right. We will give the same answer.
Yeah. So this is not the answer. They sometimes, if they are asking in this way, you need to tell them there is a process called ending process. ANDING. Ending process. Okay, so what will happen? Computer is going to convert, obviously computer understand the binary language. So computer is going to convert the binary of 10.1.1.10, okay, PC1 address, and then the subnet mask of PC1. Can you see that? PC1 ka jo subnet mask hai, okay, and the IP address. And then we are going to end the process. In ending, this is a digital electronics. If you heard about AND gates, NAND gates, OR gates, XOR gates.
Yeah,
so
yeah, yes, sir. Yes, sir.
Okay, so if you have heard about that, just forget. Okay, so listen here. So 0, 1 is 0, 0, 1, 0, 0, 1, 0, 1, 1 is 1. Ending process क्या बोलता है? 0, 1 is 0. 1, 0 is also 0. 0, 0 is also 0.
0.
So many zeros, but we want to become hero. So 1, 1,
1.
right? So this is called ending process. So the first computer will get a number, this number. So this is going to be my ending process for PC1. And the same thing we are going to check for PC2, PC1, PC2, okay, and the web server address. So now PC1, this is the address what we got, right? This is the address we got 0010 something, right? Yeah. And the web server address. So the network bits, how many network bits are there? in this /26.
Yeah.
Kitne bits hai? 26. So how many bits we are going to compare now? 8, 8, 8 plus extra 2. We are going to compare first 26 bits. And if they are same, then they are in same network. If they are not in the same networks, you can see PC1, PC2. So can you check their network bits are same, yes or no?
Yes.
Yes.
The first 26 bits are same. It means they are able to communicate with each other. Then only the computer is going to send ARP packet. So before sending ARP packet, computer is going to do this process. This process is called ending process. Clear, everyone?
Yes, sir.
So it is very rare if many will ask you, okay, like maybe out of 10 interviews, one person, or maybe out of 20 interviews, somebody will ask you ending process. But if you know about ARP also, then it's good. But if just an extra knowledge I've given you that the device do ending process, then they go and forward ARP packets. Clear, everyone?
In ending process, basically it match the subnet.
Network bits.
Yeah, network bits.
So suppose your company or your computer is try to communicate the outside network. So if you put a binary of this IP 192, and if you check that binary of this number, do you think 26 bits will match? No, right? No. पहले ही bit नहीं match हो रहा ना. Just check the binary of 10. What is the binary of 10? This. And what is the binary of 192? It's 110000. So are they matching? Are the bits matching?
No.
No, sir.
No.
No, na? They are not matching. They should be same, right? You can see they are same. Right?
Yes, sir.
So actually होता क्या है जो मैंने ending process बताया था ना, first IP and subnet mask they will do ending and this device will do ending and then that ending digits will be matched with each other, not the IPs directly. Okay.
Okay.
But if you try to compare, if you want to go to 192 and computer instantly come to know how computer understand, okay, let me ask the interview question. If I want to go to web server, how computer come to know that you are going to outside network? By checking the again
ending process.
Computer को कैसे पता चल रहा है? ये तो हमें दिख रहा है ना. This is 192. We are humans. We are able to see from eyes. Computer does not have eyes. They have logics, right? जो हमारे काम में थोड़े. Right? So computer almost do ending process and compare, and when it checks the first two digits, because 192 and 10 does not match, and instantly we come to know they are not in same network. If I want to communicate with outside network, I have to talk to my gateway. This is why we need gateway, because gateway is the only device which can help us to go outside, right?
Yeah.
Yes, sir.
Clear, everyone? How to check IP address? The command is
ipconfig/all.
But if you want to check on the router /value, okay, /value I'm talking, what is the command? Because you need to check show running config, right? Mostly. But try use this command, show IP interface, giga ethernet 1/0, whatever. It will show you the /value also. So because when you type show IP interface brief, does the router tell you the IP? Like if this is the router here, if I say show IP interface brief, can I see the /value?
No, sir. It is not showing. It's
So then normally in CCNA you studied maybe we need to check show running and then we check subnet mask here, right?
Subnet mask, yes.
So if you check show IP interface, okay, which interface I want to say, maybe GIG000. Okay, so can you see the /value, guys?
Yes, sir. /8.
Yep.
Yeah. It's very rare people use this command. It's good command, okay? And also, like there are few things like proxy ARP is enabled. Okay, so we'll discuss about those things. Okay, you can also try out all this. So you can see some TCP IP address compression is disabled. All the configurations related to IP. Even the MTU size 1500 bytes is given. The broadcast address is 258, something. All those things are mentioned in this thing. Okay, so determining IP address within a subnet, I hope you got to know. Okay, that we match slash values and all. So now let's talk about DHCP tomorrow. Let's talk DHCP tomorrow.
Sir, please share the
Yeah.
today notes.
Yeah, sir.
Today notes. These notes, right?
Yeah, this one.
So I'll be uploading the what we call the PDF document I was showing you. Okay.
Sir, in the noisy.
Okay. Just hold on. Let me stop the stream. Okay, so actually this is like we just brush up all our basics today, but
Yeah.
actually the content of CCNP, like I'm not
start.
rushing, I told you. Yeah. So CCNP content we will start tomorrow. Okay.
Okay, sir.
After DHCP.
No. It started because I've shown you something basic now, but from tomorrow,
Yeah.
like we will start DHCP. So what is DHCP? What are 4 types of packets? DORA process kya hota hai? Okay, what are like not just DORA, we need to understand discover, offer, request, decline, acknowledge, NAC, release, inform. 8 messages in DHCP. You might be studied 4, maybe.
Yes, sir.
Even
We
not
knew
4.
about 4.
Yes, sir.
Yeah. Okay, so no
Our
worries. We need to
request
learn more.
acknowledgement.
Normally 4 are important. Okay, this is to get the IP. These 4 are required. But if I want to renew, or maybe I just want to change the IP, then release is required. If I want to reject the DHCP request, then this request is required. NAC. Okay, non-acknowledgement. Inform. If I have duplicate IP address or anything, whatever issue, so this is required. Decline. Okay, that I want to decline the request. Okay, so now you can see potential troubleshooting issues. Okay, so these are the common issues in DHCP, like a router not forward broadcast. So what do you think? So when router does not forward broadcast, and if your DHCP server in another network, because DHCP, when computers send the DHCP discover, it's a broadcast packet. Yes or no? If you don't know, like we'll discuss tomorrow. Okay. So I'll show you DHCP conflict and all. This is what then we will start basic IPv6. And in IPv6, there is a concept called stateless auto configuration. We will discuss that. We will discuss about EUI 64. Okay. How many of you do not know anything about IPv6? कितने लोगों को IPv6 बिल्कुल भी नहीं आता?
मुझे सर
थोड़ा बहुत तो आता है.
I am proud of you, man. Okay, just hold on. Okay, so कल की क्लास तुम्हें अच्छे से समझनी है ना अगर? So okay, I know basic. Okay, so I am giving you all what we call IPv6 course. Okay, I need to check if I have English video. I think that's there in YouTube also. You can check, but I'm sending you guys. Okay, so use this link. Okay, so there is extra course I just shared with you. This is IPv6 course. Okay, I will check. I don't know, like I have English video for that, but on YouTube, maybe I have uploaded IPv6. This is the Hindi version. Okay, let me check if I have the English version also. Just hold on. IPv6. Okay, animated. Okay, but I configured one good topic of IPv6. Okay, I have to check, guys, for IPv6. I'll try to share with all of you. But yes, I've shared one Hindi one, but I'll share the English one also. Okay, don't worry. Maria, I'll upload the PDF in your notes. Okay, I'll share the notes file very soon. And also that link will be uploaded into your Learn portal, live portal also. I'm weak in troubleshooting. Don't worry, Sonu. Like troubleshooting is not like nobody can teach you troubleshooting. You need to learn yourself by doing practice. Lot of labs. जितना ज़्यादा lab करोगे उतना ज़्यादा troubleshooting skill improve होगा. Okay, we'll discuss about IPv6 and we will discuss about all these things, you know, right? PCR. This is what we already covered today. So this is a PC one, what we will send in ARP, what we will go in ARP cache. Okay, so just have an overview on that. This is called packet flow. Okay, what will happen? ARP request will go in the ARP reply. Okay, and the AD values. Okay, make sure you remember AD values. Yeah, Atif, the today video is uploaded on your portal very soon, maybe by tomorrow. And today I have done a YouTube live also. So you can check on YouTube also. So IPv6 static routes tomorrow we will learn. Okay, so it means, and also the best part is that there are some trouble tickets. Okay, we'll try to understand these trouble tickets and trouble tickets 1, 2, 3 like that. And this is how we will be able to complete the first portion. And then the second portion is EHGRP. Okay. Okay, fine, everyone. Thanks for joining. I think aaj ke liye itna kafi hai.
Sir, I have one doubt.
Yeah.
Sir, when we when the router send the ARP packet to the this host, no, it will not broadcast, right? It will send to particular host only.
So when your computer send packet, this is what you're saying?
No, the router computer will send to router, and then router will send ARP to the host, right? For the MAC.
No. So when you send, so listen me. So when LAN network, when your computer forward ARP, router do not forward that ARP to another router. Are you getting my point?
Okay.
So when computer send ARP, your router replies, because router is the gateway for that computer. But router is also connected with another router. So between those two routers, the WAN connectivity is there. For that, they are discussing their MAC address with each other. Okay. So between router to router, there is a network. I told you 1000. So there is a separate ARP is going between two routers, and there is a separate ARP going between router and the LAN network. So they are 192 network, 192 ARP packets will not go to the second router.
Okay.
I hope you understand now, right?
Okay. Thank you.
Okay.
So
noisy app का क्या है sir? Noisy app के लिए?
Noisy app is just a chat software where you will be able to discuss your doubts. You have not downloaded or installed?
No.
Yes, sir.
No, sir. No, sir. Please share link.
So, okay. Please share link. Let me share. So why you guys don't join?
We don't know about the noisy
We
app.
don't know about it.
Okay, so this is a chat software, okay, where I'm sending you the invite, where we will be going to discuss all the doubts. Okay, so whatever things like if you want to discuss, you can send an audio message also. Hi everyone, this is a test message, like that. Okay, so you can send audio messages also if you have a doubt.
So you told it you share a Google link for the resumes.
Yeah.
So could you please tell me the best application to make a better resume?
I recommend all of you to use what we call Canva. Okay, first see one by one. Okay, I'm sending you the. I'm sending you this chat link. Okay. Okay, that we have sent email also multiple times. I think you guys do not check your emails. So I'm just worried when Google will send you offer letter, and when you do not check the emails, what will happen? So when Facebook will send, Google will send you offer letter, you guys still ignore your emails?
We know when, sir, we know जब वो send करेगा तो.
after giving interview, sir. Yeah, we'll always keep
Okay, great. निखिल भैया तो आज पूरा सो रहे हैं.
Sir, we are using one more software, Discord.
No, Discord is okay, but we move to this application which I've just shared a link with all of you, Noisy. Okay, so we will
install in mobile.
Yeah, you can install in mobile also. Okay, just use the same link. Just join from computer and then join. Okay. Yeah, I can see many of you.
Can you please share the book, sir?
Book already shared in the notes, bro. Notes link I'm sharing again.
Okay, sir.
Sir, regarding the lab, is there any? Yeah, hi.
Just hold on. कभी-कभी मुझे लगता है बस तुम सामान लेने ही आते हो यहाँ पे.
Yeah, hi, Atul.
Yes, sir. Many times people ask only for notes.
Yeah, tell me.
Yeah, so
from last lab, tell me.
Yeah, regarding the lab, so is there any specific, for static lab I need to configure static, and for OSPF I need to do OSPF, because if you go to the lab
so
section,
basically, yeah. So this is what you are talking about.
Right. So I configure in the static lab the default route. Okay. So yeah. So the default route I have configured towards the next hop, and I try to ping an unknown destination, but it did not ping.
Okay, then I have to check. But yes, you can, guys. So when you open the CCNP lab, okay, there are a lot of labs here. Every trainer is having their own folders. Like this is by Kave, this is by another one. Okay, Pankaj and all. So they have different Sachin and all. So you can see there is a CCNP base lab. Okay, so if you follow Cisco guidelines, Cisco has this topology in Cisco, PDF, Cisco books everywhere. Okay, on this topology, we will be able to understand mostly all the CCNP topics. Okay, got it?
Yeah.
So, but yes, if you want to, but what we have done at Networkings, we are not restricting you to just do one lab. तो हमने ये नहीं बोला कि आप एक ही lab करो. हम क्या कह रहे हैं? What we are saying that you can use all these labs. Okay, even we are sharing like what we call, let me give you one more thing in my.
Sir, is this Encore lab or CCNP ENARSI lab?
No.
NRC.
This is, see, both either Encore student or ENARSI, both use same servers for labs. Okay, don't get confused. So I have shared now CCNP route something. So this covers mostly routing topic. So now I told you this is the lab number one. Lab number one, right?
One. Yeah, one.
Yeah. So now it's not mandatory that I have to explain you this, because I have already covered like static routing, or maybe I will cover more classes.
Yes.
But now you can see it's very simple. You need to go to Delhi router, enable config T, enable Hyderabad and all. Okay. So now you start working from tomorrow or only. Okay. So which lab you need to find? Day one, default routing, static route. Can you see static routing lab here?
Yes, sir.
But I have used two links. In this lab, we have only one link.
And I was unable to open that switch also.
No, this is okay. Just hold on. देखो अभी मैं तुम्हें समझा रहा हूँ पहले how to do the lab. So when you got the PDF, this lab PDF, the workbook PDF also shared with all of you. Okay, so when you want to do the lab, you need to enable the devices. Okay, and there is a device like VPC, all those stuff.
This server.
No, this is like a computer with a Linux.
Okay,
Linux,
Linux
Linux
yes,
system.
Right.
सुनो तो सही. Okay, so this is a Delhi router. You open this tab, so you can see very fast, like you got the access because all your fees invested in the servers. So,
sir, is there time limit for accessing lab?
No, 24/7.
So, sir, please allow me access to create a labs.
With
that access, no. That access, okay, let me tell you. There are some restrictions. I'll come to know that also. First, let me show you this. Restriction है कुछ, मैं बताता हूँ, पर उसको भी कैसे हम solve कर सकते हैं. I'll show you that also. So this is the Delhi router. Okay, so very fine. Everything is working, right? You do not have to install anything in your laptop. Just open this website, enter your username, password, enable config T, host name. What we have to enter here? Delhi. Okay, so which interface is this? Obviously, you do not have to check everything. You can give IP here. Which interface? FA00. Which interface? FA0. So FA00. I lost. Yeah. Yeah. FA00 IP address 192.168.12.1. Right? But I have added two interfaces just if you want to use for two static routes if you want to practice. Okay, just because somebody asked me, so this is why I have added extra link. But never get confused. This lab is not similar, but 99% it is similar, right? Just we added extra link. So don't get confused whenever you get any extra link, because sometimes student request us to add one more link. Okay, clear everyone?
Yes, sir.
Okay, so we have given IP. So we have given IP, and on the Hyderabad side, okay, so we have to do the same thing, enable. So can you see if you stuck anywhere, you can refer the guide and see the commands here, right? इससे अच्छा क्या होगा, पूरा copy paste भी मार सकते हो, but कुछ सीखना भी है. So I would request everyone to follow the guide, but try to just follow, check the guide when you get stuck. Okay. So 192.168.12.2, 255.255.255.0, no shutdown. And there is a LAN side or where we have given 2.2.2.2. Okay. And 255. This is /24. Okay. So we have given. So now what we have to check in Delhi router, like, can we ping? Okay. If you check the Delhi router, so you can see only your directly connected network, right? You can see only your 13.0 network. So can I ping 2.2.2 or this machine? If just imagine if this machine has IP, can we ping? No.
No.
And how to configure this virtual machine? Okay, this is a Linux PC. You just have to type IP 2.2.2.3. Let's give 3 /24. Okay, and the gateway. Okay, so yeah, like this. Simple. Okay, and if you want to use a question mark, it will show you how to give IP question mark. You can see this is how you just enter the gateway. So IP, then 2.2.2.2 is my gateway. Yes or no? 2.2 is my router IP, na?
Yes.
Yes. So if I try to ping my gateway 2.2.2.2, my computer is connected to my gateway now.
Yes, sir.
Yes.
So now my work that I want to ping the Delhi, or Delhi router should ping this machine. So should do you think can I ping from Delhi to the PC? No.
No.
Because
What we need, because Delhi router does not know about this network. So what we have to do now?
we have to perform the routing between two these.
Yeah. So we need to add a static route of 2.2.2.0, 255.0.0.0. Is similar like 192. No. I'm just putting the. You just want to ping Hyderabad router, or you want to ping the whole network?
Whole network.
So you have to use the network ID, na?
Yeah, sure.
Okay, so now we have given, and let's try to ping 2.2.2.3 because that machine IP is 2.2.3, and I'm not getting a response.
Sir, we have to perform both sides, I think.
Gateway.
Both side. Delhi network does not have what we call any LAN network, na? I'm pinging from directly Delhi router.
Okay.
I'm just thinking what IP we have given to 13.2 is reachable or not.
Yeah, same thing
Okay,
I did. Like I created one default route towards the next stop, and I pinged any unknown destination.
Actually the problem is, problem is I have not given FA1/0 wrong IP. Can you see that?
Yeah.
Yes.
Interface FA1/0 IP address or FA00 0, and this side, what interface I've configured? Actually, I just used the lab show IP. So FH00 13.1. So this side we have to give on FH00 13.2. Right? So sometimes we do everything and the problem is in the IP address. Right? That happens. And if I try to ping now, also
No,
the
yeah.
FH, interface FH01 also, we need to add 2.2.2. Okay, now I'm sure we will be able to ping because we have a static route, connectivity is fine. And let's try to ping 2.2.2.3. Yeah, we got the success rate, right? Yes, reachable. So the first lab is completed. Now you have a lab 2 EIGRP configuration.
Why we are using the two links between two routers?
Just if you want to use two static route, if one link goes down, still Delhi and Hyderabad has a connectivity. Just see from the real perspective.
Scenario.
For redundancy.
Real
right?
scenario. Redundancy. So we have lab 2 now for EIGRP. If you know about EIGRP little bit, okay, so you just use lab 2, open 4 routers, do the same practical, start working hard, right? ये लैब तो तुम मुझे लगता है पहले ही 10 दिन में खत्म करो इसको. Watch whenever you get stuck, try to watch pre-recorded videos also because EIGRP videos are also there. But yes, in live also we will be going to learn. But yes, if you know the topics, then it's better to discuss. Right?
Should we go with IPv6 also?
Yeah, IPv6 what?
Should we go for practical with IPv6 also?
Yes, for sure, man. IPv6 is very helpful.
Sir,
just a few days back, I've taken.
Multicast routing will be covered in this.
No. Just go and check an RC content, na bro. What is there in the CCNP ENARSI?
Okay, because my current organization is working on multicast.
You have to Encore or CCI. In Encore or CCI. Yeah. Okay, guys. So I'm closing for the day.
Sir, where we can see these files, this video files?
Video files, you go to Learn portal. Okay. Log in with your ID. तुमने मुझे support team भी बना दिया आज. Okay, so just log in. Okay, so you can check your content here. Okay, whatever batch you have enrolled for. Okay, so like this.
And sir, what about PDF files which you were?
Okay, so inside your courses only. Okay, so we have shared. Okay, so we have shared a notes and course link kind of stuff. Okay, like there is a notes link here, right?
Okay.
So this is for my another batch. Okay, like this. You will have this type of link into your Learn portal. Okay,
sir. Got it.
And there you will see, and you will able to watch all these videos from here after the class. Okay, like day 1, day 2, day 3, like this. Okay.
Okay, sir.
Okay, any other questions?
No, sir.
ठीक है भाई, जा रहा हूँ मैं. Good night.
Good night, sir.
Good night.
Good night.
Good night.
Good night. Good night, sir. Good night, everyone.
Okay.
Good night, everyone.
Good night.
कल क्लास के टाइम पे उठना है बस.